So my name is Michal. I'm going to remove the mouse. Yeah, my name is Michal. I'm a lead engineer at Just Eat. I'm a trainer, engineer, speaker, and you can find more information about me on my blog post, or you can contact me on my Twitter account. And before I go into the microservices world, I want to kind of discuss something which I call IT evolution, because I find a lot of similarities between the evolution of life and how the IT evolves. And if you look at this kind of screen, you can see here that, just like life started very shallow, narrow, kind of small, simple organism, the same thing kind of technology started. It started really simple. There were engineers, people innovating 40, 60 years ago, and they were kind of innovating in IT just to provide service to kind of business that was back then, right? So it was like IBM, or back then Apple, or later on Microsoft, companies like that. But then, just like life exploded, the same thing happened in technology. Technology really exploded, really like a lot. Right now we have a lot of languages, a lot of frameworks, a lot of different things we can use to kind of build our products, to kind of innovate. And I could replace those names of those different species and animals to kind of different technologies we have this day. What is also interesting, like in life evolution, you can also find some like dead branches. There are certain kinds of animals or species that are kind of extinct, like probably famous dinosaurs. The same thing happens in IT. There are certain technologies that kind of are being removed or killed or are not usable anymore. And my point in this here is kind of, I want to prove that there are no silver bullets really in the IT. There are no tools and products that actually solve all our problems. That's why we have this big explosion of different languages, frameworks, technologies. Everyone kind of tries to innovate to kind of find a perfect tool for their own product. So there is always something changing. And because we are on the Agile meetup, I'm going to mention this, which is waterfall. I'm not sure who here works still in a waterfall. Yeah, awesome. Yeah, that's actually proves my idea, because not my idea, but my point. So even if we think that waterfall is bad, and we should all of us should do agile, there are still companies doing waterfall, and there are still companies happy doing waterfall, or maybe kind of innovating waterfall in a different ways. Just like agile community is changing, and agile community also have different kind of concepts. Agile is not really just about agile. Agile is like huge community with different tools, different ways people operate, different ways people work. But still, waterfall is here, and waterfall will be here to stay, because there are still projects and products that require waterfall approach. So again, there is no silver bullet. Agile won't solve everyone's needs, and Agile won't fit into every product, every project. Another one, like this is like a Spotify. Like we look at Spotify, I'm not sure if you've seen their deck. They kind of are very famous for their kind of blog posts about how they organize their teams into tribes. They also have those presentations about it. So we look at them and we think that they have the perfect mix. They have the perfect team, and we should all of us should work like that. But to be honest, there are still companies that do like to work in a hierarchical, not flat, not super flat way. There are still companies that kind of like to work like that. There are a lot of companies that are kind of in the middle, are trying to innovate with something new, and are still trying to stay with something old, because not everyone is actually able to work in that kind of system. A lot of freedom, no bosses and things like that. There are still a lot of people in the world that like to work in that way. So again, there is no silver bullet. There is no way to organize team. Every company is different. Every product is different. Every team is different. Every culture is different. To be honest, cultures in our products, in our companies, they are kind of evolving. They are changing constantly, and they might be even accidental. So when you start a company, you never kind of plan to have this kind of culture. You start somehow, and this kind of grows and grows and grows and grows naturally, and you end up with something, which then you try to change. So there is really not a silver bullet around the kind of IT world. So if there is no silver bullet in technology, organizational, and things like that, why there is so much hype around? Why there is hype like, I don't know, Microsoft long time ago found an idea that they will create interviews like with questions like, how would you move the Mount Fiji? And then everyone suddenly jumped on interview processes and started asking those kind of questions, because those were supposed to find really innovative, great people. Then later on, a couple of years later, or maybe 10 years later, Google did a research, and they actually find out that asking those questions is not useful at all. because we should focus on different kind of characteristics, different kind of ways people operate, and asking questions that are supposed to open you up. This doesn't really work. Another example, looking at companies like Google, and Google is very famous for having one single repository of code for everything. So they keep all the code in one single repository. And you might look at them, oh, they are Google, they are big, they are successful, we should also do this. Well, not really. Just because Google is doing that, it doesn't mean that this is the perfect way. This works for them, it doesn't mean that it will work for you. And to get to the microservices, there are companies like Netflix and Amazon. They have huge scale. They are really successful, and they have a lot of customers, and they have microservices. So Amazon started this journey a long time ago. Netflix kind of right now is like on the forefront, really innovating about it and speaking a lot about it. But because Netflix and Amazon, they have microservices, that doesn't mean that our companies, our products require microservices. And to kind of talk about this hype, I'm going to present to you the beautiful side of microservices based on my experience, and the bad side of microservices based on my experience. Now, those are screenflow heroes of Might and Magic 3. I'm a geek, I'm a computer gamer, that's why I put it here. Okay. So my experience, what I'm going to say today is based on Just Giving, which when I was involved in moving from a monolithic application to a microservices-based application, from hosted servers to the cloud. And this is also based on my experience in Just Eat, when Just Eat operates only on microservices, and all of them are event-based, message-driven, with architecture like that. And just to kind of tell you how I think about microservices, quick recap. So when I think about microservice, I see a easily replaceable, single deployable, something that does a single business functionality. I don't see microservice as 10 lines of code, 100 lines of code, or 1,000 lines of code. I believe that microservice is something that provides a single capability. And it can even be as large as 10,000 lines of code if this single capability really requires that kind of amount of code. On top of that, I believe that if you want to have microservices, you have to have your culture which is DevOps enabled, or like Ian Cooper recently said something, service agile infrastructure. So service agile infrastructure means that there is no ops team, there is no DevOps team, and everyone in a product team is involved in building something and delivering into production, then monitoring it and supporting it. So everyone is involved. And I believe that all the microservices should also be message-based. Now, this brings a lot messaging-based. This brings a lot of difficulties, a lot of interesting problems. But I think that if you want to have microservices, this is how, in the end, you will have to operate. When it comes to architecture, when you have a monolithic architecture, in this example is like a port, an adapter, Uber-based kind of app. You have a single big core and then some adapters around it. With microservices, you have split it around, and you have single deployable, easily replaceable pieces of software that communicate with each other. In this example, through a REST API. So beautiful things. So there will be 3 of them. Scalability, flexibility, and independence. This wouldn't be a talk about microservices if I wouldn't mention scalability, but there will be a little twist to it. So, by scalable, we mean system that is able to cope with bigger load, more customers, and things like that. But the better explanation is, scalable system is a system that you can easily modify it or easily add to this system, and this system will easily be able to support more load. So it doesn't mean that your system is not scalable, probably that it's able to handle 1 million users, but right now it's handling 10,000 users. Your system is scalable if it will be able in the future to kind of operate with 1 million users. So that's a scalable system. In a monolithic approach, if you want to scale monolith, you kind of do it vertically by increasing the monolith, adding more RAM, CPU, and things like that, increasing the machine where your database is running. Now, this is limited. There are hardware limits, there are CPU limits, memory limits, and things like that. So vertical scaling is working for a certain degree, but then it kind of falls down and just it's not really good. So to fix it, you kind of scale it horizontally, which is like a multiply the number of boxes, which is also working to a certain degree. But I believe that after some time, you will hit some problems and you won't be able to scale again. So This is something I found somewhere in internet. You have a link here. And they define scalability in like this scale cube. And they have 3 different axes that you can scale your system. So the first one I just mentioned, which is horizontal duplication, which is like you add new boxes, is like X here. The other one, which is microservices, is like Y-axis. So the other way to kind of scale your system, you kind of decompose it functionally. So you split it down from the monolith to multiple smaller systems. And the last one on how to scale system is data partitioning. So you take your big monolith and you can also split down your monolith, your monolithic database into smaller databases handling different kind of data. So in Y-axis, if you want to functionally decompose it, you just take this big chunk of monolith and you split it down into services, have some UI layer and database. Then you add the data partitioning, you add another level of scalability or scale, and you kind of split down your database into multiple different chunks. And now, the benefit of microservices and doing that in that way is that you gave yourself and your system a flexible approach to scalability. Because right now, you can surgically scale your system. So instead of making your whole monolith or multiplying it or making it bigger, you just kind of check out where your system actually needs scale, like in this example, content service, and you just multiply this service. Then you find out that database right now is a bottleneck, so you just modify this database. Or maybe your ordering service requires another database, right? So microservices and splitting around this monolith into smaller pieces of code or smaller pieces of deployable parts means that you can flexibly scale it. And that's how I see as a scalability benefit from microservices. So monoliths, and I'm going to show you an example later on, monoliths are also scalable, and monoliths are scalable in a way that will suit probably a lot of companies, a lot of products. Microservices are a lot more scalable in the future or kind of support bigger scale if your product grows and grows and grows, but microservices bring in also a lot of costs. So flexibility. If you kind of change your system from one big monolith to kind of smaller, simple parts, you are much more flexible to make decisions like which technology to use in this part or that part, which language to use here or that, which framework to use here or here. Now, this brings a lot of other difficulties, like if you have too many technologies, you kind of gain too much, probably cost also, but at least you have this flexibility, and you can decide that maybe for this part of the system, this technology will be better. You don't have to stick to Java or C# or, I don't know, something else. You can decide that for this part of system, for this product, or this feature, we can kind of build it using this technology because this technology will be much more suitable. There are also other flexibility things like you can add maybe eventual consistency to one part of your system, which means that some part of your system is using stale data and you're fine with that. Or you can add, if you are a distributed system like microservices, there is a huge problem with how to deal with transactions. So with this system, you can decide that maybe this part, smaller parts of system, or one part of system requires distributed transaction, or maybe other part of the system requires AC transactions, which makes your system synchronous. Even if it's kind of distributed, it's still synchronous. So it gives you this flexibility on deciding which and how to kind of work with your kind of bigger system, instead of having this one big monolith, which is kind of, you know, it's one big thing that you can still do those things, but it's like less visible. And freedom. So I work with Just Giving, and we have this big monolithic system with 30 developers working on it, and everyone is working on the same branch, and there were huge problems on how to organize everyone, how to make sure that we deploy our releases. Working on the code base meant that we spent 1 week developing product and 1 week orchestrating everyone, 1 week testing everything to just be able to kind of release stuff to production. When we moved to microservices, we kind of found out that naturally, people tend to gravitate to the services they were working on. So if you gave someone a responsibility that, okay, you are responsible for this service or this piece of our business logic, then people kind of started creating teams of their own, really. They felt responsible for their services and then naturally become independent. You also can create independent teams in monolithic approach, but I think with microservices, it's kind of also you're also influencing or putting much more pressure on your culture to make sure that this independence will stay. And of course, independent deployment, because if you do it properly, the teams are not kind of dependent on each other. They can kind of release stuff separately without affecting each other. And independent development, you don't have to wait for someone to finish something, because you can deploy your stuff, add a new version, and then let someone know that, oh, we have new versions for you, because in the future you might use this one, or like in 2 weeks. They don't have to wait for you, because it's already there, it's already being released, and it's already there. And of course, you also have independent tech, which is also the flexibility. Now, but I want to focus in this talk about the bad side of microservices, because I think that there is too much hype about it, really, and too much people think that it's really something which will solve all of our problems. And that's not really the case. And a lot of people have problem with cargo code. So looking at companies like Netflix or Amazon, thinking that because they are successful and because they use microservices, then we also should use microservices. And that's really a huge problem, because they have their own problem, they have their own product, they have their own context, and they kind of started doing things their way. Now, your way and your product and your companies will be completely different, and it doesn't mean that you have to go to microservices world. And I like this screen, because this one shows kind of hype cycle, and with time, there's also expectations. So when a new technology starts, everyone kind of is really excited and want to jump on it, want to use it, want to try it out. But jumping on new technology in this moment is really risky, because no one actually knows yet how to use this technology. An example of microservices, there were companies doing this long time ago. There was something called service-oriented architecture, which also, I'm not going to say failed, but we can talk about it later. Well, it actually didn't fail. Service-oriented architecture stayed with us, and microservices are the new incarnation of it. Service-oriented architecture died because of big vendors trying to capitalize on it, really. Big vendors took really great idea and tried to make a lot of money out of it, and this kind of killed it, because they kind of overhyped this idea. They pushed it to too many companies. Those companies kind of failed horribly, and then SOA became really something, oh yeah, we tried it, but it didn't work for us. So when you jump on technology in here, it's really risky, because new technology still hasn't been discovered. New technology still haven't been tried. There are no patterns. There are no experienced people. There might be people in really big companies that are able to afford really expensive people to work there, but otherwise, the kind of knowledge is not available in the community. Then this hype kind of grows, and in this moment, a lot of companies that started using new technology like microservices, they start to realize that, well, actually, microservices don't work for us, and this was a failure. And they try to spread around this, like they start to complain and put blog posts, oh, this doesn't work for us, this is broken. Just like there was a huge, I'm not going to say scandal, but there was a huge story about MongoDB, and someone used MongoDB and then expected the same characteristic of a database like in SQL database. But then they used MongoDB and were completely surprised that it doesn't work the way they used to. So when this starts, the hype slowly drops. And this is where companies that actually use microservices or different technology, or other technology in a correct way, they stay behind, because they believe still that this works for them and this is okay, this is great. And slowly, those companies, just like ShopDirect today and SAP, start sharing their knowledge, start creating tooling, start creating patterns like microservices boilerplate, and suddenly, we kind of get to this. I think the microservices are right now somewhere between here. But suddenly in the future, we will get to this point where there will be already a lot of knowledge, a lot of patterns, a lot of people that actually build things with new technology. There will be also tooling and things like Microsoft boilerplate from ShopDirect, things like that. That jumping on this new technology will be a lot cheaper for everyone. And this is like kind of democratizing the technology. At the beginning, only really the companies that have a lot of money to spend, they can innovate, and then everyone else can follow. But a lot of products in our companies, they don't really need innovation in technology. Mostly they really need innovation in kind of how they operate with business, marketing, things like that. So sometimes it's really good way to kind of wait for this whole hype cycle to kind of. It's sometimes good to wait for someone else to pay the price, right? To find how the new technology is really good. It's really good if someone else will just do this and share the experience, and then you can kind of see that, oh, this technology survived. Oh, people are still using it, so there are already tooling, there's already books, there are already knowledge around the community, so maybe it's a good time to start. So this is like one of the things I see in the community, people thinking that microservices are really like the best thing in the world, while really there are a lot of problems with it, and problems like, do you really need microservices? Because if you know engineers and developers, they like to fix stuff, and they like to work on stuff. But sometimes they imagine they have problems which are not really problems. And this is like a nice book which says solving imaginary scaling issues. Not a lot of companies really have scaling problems. A lot of companies can just work without thinking about it yet. A lot of startups especially kind of start fixing scaling issue when they don't even have a scale. They still haven't discovered what the business is really about. They still haven't discovered their market niche. They still don't have customers, but they still start thinking about scaling issues because probably the technical department has too much power in the company. Another thing, if you are from Ruby community, you know this guy. I'm not a huge fan of him, but he wrote something which was really good, something like, programmers worrying about whether the architecture will web scale is like buying a lottery coupon and fretting about which yacht to buy, right? So it's kind of something like that. You first have to really hit problems or anticipate them before you start trying to fix them. Now, anticipating the problems, that's really difficult. That's why you need really experienced engineers. An experienced engineer, it's a person that won't just start scaling stuff. This will be a person that will tell you, okay, in next 3 months, with this growth, we will need scale. And this is really an experienced engineer. If an engineer comes to your company and without any test, without any analysis, tells you that we need to invest in this and this, in this technology, we need to scale this, do this and this is not really an experienced engineer. This is someone that is still learning. And you can find a lot of examples. If you are a developer or engineer, you probably know this site, which is Stack Overflow. And they have a Stack Exchange. They have a lot of different sites with question and answer, something like Quora. And they were actually, I think they were the first one. Quora was the next one. And they have a monolithic architecture. And they have 300 requests per second. They have thousands of requests. They have a lot of people using them, and they are monolithic. They are fine with that. And if you see at those examples, they have peak usage of CPU around 12%. And they're using only 4 databases in 2 clusters. That works, right? They are pretty big. It works for them. So if it works for them, then why do we think that monolith cannot scale? Monolith can scale and is able to scale. So this is another thing. If you go with microservices, there's a lot of, I did this mistake. So I was mostly a developer that was working with monolithic systems. And when you work with monolithic systems, you tend to ignore something which is called network layer. You kind of don't care about it because you operate in a monolithic system and it kind of has those processes working there, but this is working inside operating system. So it kind of works because it was already fixed by people 40 years ago. But if you go into microservices, you kind of distribute your system, and then you have to learn what it is and what it means to work inside the network. And network layer is really, really, really nasty beast, and it adds problems like latency, problems like complexity, because you have to think about it. You have to think about network when you build your software. Things like debugging. Debugging inside your single monolith is very simple. Debugging when you have monolithic microservices distributed system is much more complicated. Security issues, which one of those was mentioned here. And connectivity. Network is something which was built a long, long time ago, and it's a really great piece of technology that was developed by really interesting people. And network is built in a way that it assumes that it can sometimes fail. It can sometimes partition, like one part of the system is not available to the other part. That's why you get problems like Facebook is not available in London because network has partition and DNS addresses are completely broken and you don't have connectivity. So you have to really think about those things. So microservices, they add this layer of complexity. And you can't really beat the nature of network. It was built like that. And if you want to work with network, you have to play by its rules. You can't just tell network, we're going to play with those rules. No, if you want to work on a network layer, you have to follow the rules of network. And you have to assume there will be problems, and you have to change a bit the way you operate and the bit you kind of build your software and code. Another thing, this is one of the products I built. And I call it micro-monolithic architecture. And if you look at it, it looks pretty complicated, right? It looks almost like, if you wouldn't know that those are actually microservices, you would start thinking that those are actually services in monolith, because it's kind of looks not that good. So the problem with this is that if you have your monolith and you decide to go microservices, and you think that moving monolith to the distributed world with microservices is easy, and you can just move the thing you build to microservices, it doesn't work like that. Because most of the monoliths that we build, they have I call accidental architecture. When you build your product, you kind of don't know yet what you're going to be doing. So we are still kind of discovering, okay, we need to do this, we need to have those features. Oh, this feature didn't work, so let's remove it. And you also do coding. So you do those things together. You discover your problem space, your domain, and you also build your software. And this leads to accidental monolithic system. And if you move this accidentally built system, which worked fine for you, but you want to go to microservices, and if you just move it like that, you might end up with something like that, which is like the same mess you had before, but you just added a network layer, which adds another layer of complexity to your mess. So instead of having something better, you actually created a lot of problems. So this is the moment you want to go microservices. This is a good moment when you want to start thinking about things like domain. And there is something called domain-driven design, which is getting a lot of traction. So when you do this, you already with your monolith, you already explored your problem space. You already explored what you want to achieve. You already have kind of customers, and you want to work with them. So you don't have to do this exploration again. And this is a great opportunity to kind of take this domain, your core logic, and think about it differently. And when you move this transition, to maybe change it in a way that it will just look better. So you just don't want to forget about it. And this is one of I've seen this example of this happening a lot in different teams. Another thing, with monoliths are mostly based, at least from my experience, on one big monolithic database. So initially, when I've seen all the teams building microservices architecture, they do something like that. They kind of assume that we're going to have this one database and everyone will be connecting to it. Now, this adds a new layer of problems because you have now a single point of failure, because if this database goes down, everything goes down, so you don't have any benefit of doing microservices. If this database is slow, then it doesn't matter if you scale your microservices, because this database will be a bottleneck. So you have to remember, while doing this kind of transformation or going with microservices, just don't follow this step and think about something which is data partitioning, thinking about your data differently. If you build new microservice, think about if you can take the big monolith, cut it out a bit, and also when moving the code into microservice, to also move the data with it. And you can achieve that, because I believe that code kind of structure follows the data model. So if you have the data model is actually affecting your code a lot in a lot of companies. And if you want to have distributed system like microservices, you also have to distribute your data. And I think there is no other way. Now, you can work with this one big monolithic database for a while, but after some time, it will become a problem. And the last one, thinking that microservices are only about technology. They are not only about the technology. If you go that route, you also have to change the way you operate in a company, change the way you kind of structure the team, change the way you kind of structure your organization. Because if you want to adopt microservices, I think you also have to change a lot of things, and you have to distribute your teams. So teams have to work independently. Teams have to work separately from each other. You can't just tell the existing structure, existing organizational, let's work distributed, let's work with network layer, let's work with this system, and people will just get it. No, it doesn't work that way. Now, in example of company I work in, which was Just Giving, it kind of happened naturally that those teams kind of changed, but this kind of costed us a lot of time. So it's really good to start thinking about it when you kind of try to do this move. And DevOps. So ShopDirect also mentioned it. They had this nice monitoring, Grafana. There is something called Elk Stack, which is kind of a lot of 3 different set of tools that enable to do this. If you go to microservices, distributed work, and you add this network layer, which can break stuff, which is difficult, complex, you need to have proper monitoring, you need to have proper alerting, you need to have proper logging, you need to have proper infrastructure as a code, because like ShopDirect showed, you need to have a system that will enable you to quickly move this code to production, because otherwise you don't get any benefits out of microservices. If you will be doing the same thing like with monolithic system, then you will have 20 monoliths to just deploy and have this problem, the previous problem multiplied 20 times. So, quick summary. I believe that both monolith and microservices, they are tools. They are really useful tools. And they are both green because I don't believe that one of them is better than the other one. Those are only tools available in our tool belt that we can use to build our products. It's up to you to decide which tool is better. Do you want to be monolithic or do you want to be microservices based? Now, this decision might not stay with you for long, because if you want to go monolithic in the beginning, because it's simpler, it's easier to develop stuff at the beginning, and you still don't have customer, you still don't have scale, you can build monolith in a way that will later on easily enable you to go microservices. So it doesn't mean that you have to go microservices straight away. There are even people mentioning that for the problem space and exploration of your domain or your market or your customers, it's better to go monolithic, and then with this monolith already being there, move to microservices. Now this might change because, like I showed you in the hype, the companies are still sharing the knowledge, and this notion might change. With more tooling, with better support from cloud providers like AWS or Azure, microservices might get better and better and better. And with new hype on the horizon, which is serverless, microservices might be even completely irrelevant in 2 years. So I believe the microservices, they are a costly tool to kind of solve problems in your product. And those problems, when you solve them, they should provide you a lot of profits that you will be able to cover those costs of introducing microservices. And this is like really good quote. The first rule of distributed systems is don't distribute your system until you have an observable reason to. This is really important because going distributed is really not easy.